In this video we are going to discuss about our final year project, which is AI Accelerator design for RISC-V. So Assalamu alaikum, my name is Akif Ijaz, and in the first part of the video I will be walking through some of the complementary slides that I want to discuss before we begin with the actual project demo. So first of all, we are going to use the RISC-V architecture to create an accelerator. By accelerator means that can make things fast, and the things by means is actually any applications where we are using AI, machine learning and deep learning, which we see a lot in nowadays. So in those applications, if we understand at the base level, there is some kind of computation that those AI algorithms are actually doing. So if somehow those computations can be faster, we can understand how our actual algorithm can be perform well, and we can have much better, faster results. So with that motivation we have this project, and it is actually divided into three parts. So we will directly begin into the milestones, and the first thing we have done is actually understood how RISC-V is actually work. So we have created a processor actually that gave us a broad understanding about how we read instruction, decode, give to ELU, and read write data into RAM. So these all thing about the RISC-V instructions and the RISC-V architecture we have a good understanding by our this project. So next we have partner with some US based company named Accelerium, which has some open source accelerator named Matmel. So they have their project that is actually do some effective matrix multiplication. So we have a plan to work with them, and they asked us to do extensive testing for their already uh, build design, and also they asked us to modify the things they uh, that we think could make a difference. So the first big step was in this project was to test their test their uh, project that we did, and after that we actually have decided to create our own accelerator, which is 2D convolution. So that is also based on mathematical concepts, because if you look at the base level, there is some kind of multiplication happening in convolution also. So we just have to figure out and modify the design in such a way that it can work as a convolution. So if we talk about the architecture of Martmel, we can see these are some of the important things that they have used in their design. Like task sequencer is basically used to control the task, which task is at what stage, and uh, when we have to read the next task and when we have to write the previous task. These all information were handled in the task sequencer. So there were also the RAM part, where they have stored the temporary and the permanent storage. So the SRAM is actually can also be write back into a file, so that makes it like a permanent, if that makes sense. So the controller was actually used to control the flow of programs, like they actually control when to load and when to compute, and when we are actually done with the computing and we have to write back. So the architecture part, we have the architecture, but we unfortunately cannot show because their project is still not completely open source. So we have restriction to show that, but I hope this slide gives you the basic idea how what important things they have in their architecture. So the next thing I would like to discuss is the changes we have done to make their matml into a 2D convolution module. You can also check out our GitHub to see this project. So you can see there are some kind of constraint we have set. We have the matrix constraint, and we have the kernel constraints. The data width is 8-bit, and we have also encountered the multi-procedure in that, which means that we can also change it to 16, 32 and 64-bit as per our need. And there are a bunch of convolution type, and we are using the valid type because it doesn't have to encounter the padding thing, and it is kind of simple than other convolution types. So if we talk about the architecture, so you can see there are three main modules that we have created. So the first module is convolution 2D, which is actually a very small module that actually have one row and one row of matrix and one row of kernel, and it actually multiplies both rows and adds some individual elements and returns back. So the compute is basically have some kind of parallelism, which cause the three copies of convolution to the, and you can understand in one cycle we can have the answer of 3 by 3 matrix, and the results goes back into the RAM. So these all things were controlled by the controller, like how, when you have to read the data, and when you what data you wanted to compute right now, and the data you have only computed at which part you wanted to write. So these all things were controlled by the controller. So if we look deep into this controller, so this is actually a state diagram that actually represents the functioning of controller. So you can understand there are some kind of states that represent the different stage of the program. So we have actually checked for the column, rows, and we actually keep track of when data is computed so that we can write back. So this diagram is very simple, that actually give us the basic idea of how our convolution design was working. So this is all about the project generally.